Hello ladies and gentlemen, my name is Mr. Zeve and today we are going to evaluate the inverse Laplace transform of 1 over 2 product of linear functions s plus 3 s minus 4. So in order for us to evaluate this Laplace transform, we have to decompose this fraction. So I'm going to decompose this fraction. So I'm going to write s plus 3 s minus 4. So we can see that this partial fraction, it actually has two linear factors, and if it has two linear factors, then there exist two real unique constants of a plus b. But the one for a is going to take this denominator s plus 3, and then the one for b will take this denominator s minus 4. This is what we are having right there. So we are going to focus on this fraction. That's what we are going to focus on. So in order for us to make this denominator the same, I'm going to take a multiplied by s minus 4. So it's going to be a s minus 4 plus b s plus 3 all over s plus 3 multiplied by s minus 4. That's what we're going to have. So we can see that this denominator is actually equal to this one. So if these denominators are equal, therefore the numerators are equal. A s minus 4 plus b s plus 3 is actually equals to 1. It's actually equals to 1. So I'm going to show you a trick on how to solve this. So we are going to say a s minus 4 equals to 1, and also say that b s plus 3 also equals to 1. But I can just write a subscript a here to show that this, and subscript b to show that this is the value of s on a and this is the value of s on b. So how can we get these values? We know that s plus 3 equals to 0, s subscript a. So s subscript a will be minus 3. So this is the value of s on a. So but what is the value of s on b? It will be this one. S subscript b minus 4 equals to 0. So s subscript b is actually what? It's actually 4. So this is what we're going to do. We're going to take this and substitute in this equation. So if I substitute minus 3 minus 4, it will be minus 7, which is equal to 1. So if I divide by minus 7, I divide by minus 7. So my a will be minus 1 over 7. So even here, this will be b. If I substitute by 4 here, it will be 4 plus 3, which is 7, equals to 1. So if I divide by 7 and divide by 7 this side, my b is actually 1 over 7. So I can substitute here now, since I'm having my coefficients, my values of a and b. So minus 1 over 7 over what? S plus 3 plus 1 over 7 all over s minus 4 is what I'm having. But this is actually equal to this partial fraction, 1 over s plus 3 s minus 4. So if this is equal to this partial fraction, it means that the inverse Laplace transform of this one is actually the same as the inverse Laplace transform of this one. This is what it means. This is what it means. So, but we know that the inverse Laplace transform of alpha x plus beta x1 is the same as where alpha and beta are constant. So we are going to distribute this Laplace transform throughout the brackets. So it's going to be alpha inverse Laplace transform of x plus beta inverse Laplace transform of x1. So this is what we are having. So we're gonna use the same notion to decompose this one. Let me erase this part. So now we can see, let's check. We can see that 1 over 7 minus 1 over 7 is constant, so I can take it out. So this will be inverse Laplace transform of 1 all over s plus 3. I'm distributing the Laplace transform throughout the brackets. So this 1 over 7 here, it's also constant. I will take it out and distribute the inverse Laplace transform of 1 over s minus 4. That's what we are having right there. But we know that e to the exponent at is actually equals to the inverse Laplace transform of 1 over s minus a. So we are going to use this rule to find the solution for the Laplace transforms. So minus 7 minus 1 over 7 will be, this Laplace transform I can replace by e. But this a is equivalent to this 3. But this 3 in this case is positive. So s plus 3 equals to 0. Our s is minus 3. So that's why I'm going to have minus 3 times t, times this t, plus 1 over 7. I'm also going to replace this Laplace transform by e again. But this 4 is equivalent to this a in this case. So I'm going to substitute here. So it's going to be positive 4 because of it's a negative there. So it will be positive 4t, which is equals to the inverse Laplace transform of what? 1 over the product of two linear functions, s minus 4. So this is how we evaluate Laplace transform of partial fractions. So if you enjoyed this session, please subscribe and share with your friends. Thank you so much.